In this video, I'm going to present proportions, ratios, and rates. Considering they are quite similar, I'll focus first on proportions because they are more general, if I can say so, but the same principles apply to ratios and rates, and as we're gonna see later. Let's start by defining a proportion. An equality of two ratios is called the proportion. Something like this. Two ratios, one ratio here, another one. As you can see, I use some colors because the four terms have some names. The first one and the last one, because when you write them, you read them this way. A over B equals C over D. So the first and the last are called extremes, while the ones in the middle are called means. Extremes, A and D, and B and C are the means. The proportions have pretty much one single property, which I'm going to call the fundamental property of proportions, which states that for any proportion, the product of the extremes equals the product of the means. So in other words, this thing, the product of the extremes, A and D, equals the product of the means. We're going to use this property many times, many times. And a lot of times you're going to have out of these four terms, one of them, or maybe more of them, will contain at least one variable. They could contain more variables, meaning more unknowns that you need to find in an equation. And let's see how we can have it a little bit faster than going through this. So I'm going to show you a shortcut, let's say. In my proportion, I assume I'll have one of the terms to be the unknown. It doesn't matter which one, so I'll start with one of the extremes. So X here, and the other ones are gonna be B, C, and D. I need to find X, remember? So considering the fact that the product of the extremes equals the product of the means, I can say X times D equals B times C. I need to find X, right? For that reason, I will have to divide both sides, as in a normal equation, by this coefficient, this factor, D. Both sides. If I factor, I'm going to have X equals B times C over D. What do you notice here? X is one of the extremes. The other extreme is D. Where do you find D? In here. Let's see what happens if we need to find one of the means. So case 1, when we found an extreme, and case 2, when we have to find the mean. So A over, and here is D. Which one of them you prefer? It really doesn't matter which one is the unknown. I'll choose this one. So similarly, the product of the extremes equals the product of the means. I could start with X times C equals A times D, it doesn't matter. Or I could just say A times D, the product of the extremes equals the product of the means, X times C. How do I find X? By dividing both sides by the factor that is multiplied by X. So by C, both sides. If you simplify, you have X equals A times D over C. If you're looking at this, you can see X is one of the means. The other mean is under the fraction line, just the same way here. When you find an extreme, the other extreme is under the fraction line. And on the top, there are the other two means. So x as a mean equals the other mean underneath and the product of the extremes on the top. So let's see how that looks like in here. For example, if I wanted to find a, I would write, or a equals b times c over d. Or if I want to find one of the means, b, for example, equals the other mean is under the fraction line and the two extremes are on the top. So as a rule, you can have it, if you want to find the mean, equals a fraction line, the product of the extremes on the top, over the other mean. If you want to find an extreme, equals fraction line, the product of the means on the top and the other extreme at the bottom. Let's have some questions. So 2 over 3 equals, I'll start with an easy one, equals 4 over x. Okay, obviously you can tell me from whatever you've learned that x is 6 because I multiply both 2 and 3 by 2 to get so I have to multiply 2 by 2 to get 4. That means I have to multiply 3 also by 2 to get 6. But let's see how that works with proportions. Therefore, x equals fraction line. So which one goes underneath? The one that is paired with x. So x is an extreme. The other extreme will go underneath, 2 here. And the other two terms, so the means, on the top, 3 times 4. You can simplify, or you can just multiply and do the division. X equals, I can simplify by 2, so 3 times 2 equals 6, as we said that. So now that's an easy one, okay? But what if you had 3 over 5 equals x over 9? How would you find it? You wouldn't be able to use the same method as here, multiplying by the same number, because 3 times what equals x, or 5 times what equals 9? We don't know. So that's where proportions are helpful. Therefore, x equals fraction line. Which one of the other 3 terms go on under the fraction line? So x is a mean, the other mean is 5, so 5 goes underneath. The other 2 terms, which are the extremes, the product on the top, 3 times 9. I cannot simplify, so x equals 27 over 5. And you can just turn it into a mixed number or just leave it like that. So 5 wholes and 2 over 5. That's the answer. I'll show you another one with x on a different place. So I've had it here. I've had it here in the first example. I had it here in the second example. I'll choose it here in the third one. And just random numbers, 4, 7, 5. Therefore, you tell me, x equals fraction line. Which one goes underneath? So x is a mean. The other mean is 5. So 5 goes underneath. And 4 times 7 will go on the top. X, I cannot simplify. X equals 28 over 5. I'll leave it like that. Question 4, where I'll have to show you an example where x is here. 3, 6, 7. Therefore, x equals fraction line. Which one goes underneath? X is an extreme. The other extreme is 7, will go underneath. So 3 times 6 on the top. I cannot simplify, hence x equals 18 over 7. I hope this is clear. Now it will be your turn to stop the video here and solve the questions on the handout. That's called proportions. Now let's see how proportions, ratios, and rates are similar. A proportion, as I was saying, it's an equality of two ratios, A over B equals C over D. Ratios, you can write the same thing in a different way. Remember, the fraction line is a division, so you can use a similar sign with divisions. A to B equals C to D. And rates, you can use a similar sign to division, which is the slash. A to B equals C to D. But how are they different? So I want you to notice, though, the extremes and the means. Extremes are on the outside and the means in between. That's where the name comes from. Extremes on the outside and the means in between. How are they different then? Why do we need ratios and why do we need rates? Let's see what a ratio is. A ratio is a comparison between two numbers that have the same units of measurement. For example, is boys to girls, pears to apples, I don't know. And rates is a comparison of two numbers that have different units of measurement. I want you to remember that usually you see that notation used in, for example, kilometers per hour. So that will give you an idea that we're using different units of measurement. But the same procedure that you've learned in proportions to find one of the unknown terms, you can apply it in here. I usually take the ratio or the rate and rewrite it in the proportion form so that I won't bother which one is the mean, which one is the extreme, because we use proportions a lot. This is it for now. Watch the next lesson, which is direct and inverse proportionality.